I'm Edgar, one of the engineers here at BNC AWGs, and I'm going to show you how we can use our Model 670C or any of our arbitrary waveform generators to generate a sequence of pulses. In this case, I'm going to be mimicking the pulse that would come out of our BH1, as that unit is now no longer being made. So I'm going to show you how you can duplicate that signal just using an arbitrary waveform generator. The UI of our 670C, and right now it's just on default settings, so you can see it's just doing a standard sine wave. And I'm going to turn channel 1 on so you can see it's just outputting a standard sine wave. So here we're going to add an entry. So we have two entries in the sequencer here. We can have up to several thousand waveforms in the sequencer. It kind of depends on what you're doing, but here I'm going to show you how to build a tail pulse using the exponential rise and the exponential fall or decay. These waveforms are built into the 670C and any of the other Model 600 ARBs like the 675, 685, and all those also have these built into the AFG. So here we just have a typical exponential rise, exponential decay at 1 volt to -1 volt, and I can show you what that looks like on the screen. And here you can just see, standard exponential rise, exponential decay. Now, to get the timing you need, if you need a specific frequency, to get the frequency we need, I'm going to set the unit to advanced right here. And then we can go into the trigger, and this is what it will be our period of interval, and I'll show you where this comes into play later. So right now it's set to 1 millisecond. I'm going to keep it at that, so roughly, with frequency it's going to be 1 kilohertz. So in order to actually get that to take effect, we go to edit entry, and here is where you can pick how you want to jump between sequences. For this particular example, it's going to be a fairly straightforward sequence from sequence 1 to sequence 2 and then back. So what we do here is we'll set this to timer. This will cause this to wait for the timer 1 millisecond to reset each time before it starts outputting the next waveform. So close this, and now we can start outputting, and you can see my period has changed to 1 millisecond, so I'm outputting at roughly 1 kilohertz, even though it's the same exponential rise, exponential decay waveforms. And here we can set the lengths and durations of the exponential rise and exponential decay depending on what kind of rise time and fall time we want. It's not going to be exact. It's roughly, if you need, say, a 50 nanosecond rise time, it's roughly 4.5 times that to get what you need. So let me just pick a random number here. Let me do 450 nano and make sure this is set here. And I want this to be interpolation and decimation, so it keeps its standard wave shape. So when I start outputting that, you'll notice that on here the waveform has gotten significantly smaller, so you have the smaller rise time. And you can also do the same thing with your exponential decay. So here I'm going to say I want a 100 microsecond fall time. I'm going to set this to, let's say, 500 micro. And what does that get us here? It gives me a roughly 100-ish microsecond fall time. You have to play with that a little bit because it is an arbitrary waveform generator. We're dealing more with how many points and how long a waveform is going, as opposed to the frequency like you would with a pulse generator or a dedicated delay generator. So that's one of the many ways that you can generate a tail pulse on this unit. I also created parametric waveforms that more in line fall into what I wanted to see. And in general, it's just however you want to do. Arbitrary waveform generators are extremely versatile. So if you have any type of waveform that you need to see, or you need to mimic any of BNC's equipment no longer being produced, give us a call, give us an email. We can see if it's something that's feasible on our arbitrary waveform generators or any other products that we may make. Thank you.